Today we're looking at a relatively simple question relating to mass, acceleration and force. So we're actually looking at Newton's second law, which is shorthanded to F equals ma, or force is mass times acceleration. So if we look at the question, the car is accelerating at a constant rate of 1.83 meters per second squared. That's important if using F equals ma. The fact that it's constant rate means we can use F equals ma. If that wasn't the case, we couldn't. So on a flat straight road, and the force acting on the car is 1.870 kilonewtons. And if you get into the habit of underlining these numbers as you're reading them in the exam, you are more likely to spot that kilonewtons. So we're going to have to do a conversion. Calculate the mass of the car, and it needs to be three significant figures. So the equation I just mentioned is going to be force is mass times acceleration, or F equals ma, but we're asking for the mass. So we're going to need to rearrange this equation. So if we divide both sides by the acceleration, we get force over acceleration equals mass. Okay, well mass is the force over the acceleration. So we put the numbers into that, and this is where people went wrong. They put 1.870 divided by 1.83, but of course it's actually in kilonewtons. So you could either type 1.870 times 10 to the 3, that's in kilonewtons, or if you're happy doing the conversion, 1 kilonewton is 1,000 newtons. So you're moving that decimal place 3 places. So you could write 1,870 divided by 1.83. Either way is fine. You put one of those in, and you are going to get an answer of 1,021.86. But of course, that's three significant figures. And you might be tempted to say, well, that's one significant figure, and there's a second significant figure, and there's the third, and ignore the zero. You can't ignore the zero. When you look at significant figures, once you've got a proper number, everything after that counts as a significant figure. So that's going to be actually, that is the answer to three significant figures. And we are talking kilograms, so that's fine. And then the second part, the car accelerates from rest for 16 seconds again. From rest is kind of key as well. It tells us it starts from zero velocity. We need to calculate the speed of the car. And here we've got to use the fact that acceleration is the rate of change of velocity. So our acceleration equals the final velocity, that's v, minus the initial velocity, which is u, all divided by t. Or a equals v minus u over t. Okay? And again, we can multiply both sides by t to get at equals v minus u, but we know it starts from rest. So actually, u is going to be 0, so we can ignore that bit. So we actually get the velocity is the acceleration multiplied by the time. So the velocity is the acceleration, 1.83, times by the time, which it says in the question is 16 seconds. We pop them into the calculator, and we get 29.28. And again, you could write that out. It doesn't say a number of significant figures, so that will get you all the marks anyway. But if you wanted to do it against three significant figures, you can go 29.3 meters per second. And that's how you do that.